In this video, we are discussing how to draw free body diagram easily. Here we are discussing 5 different models to draw free body diagram. Once you solve these 5 different examples, you will definitely get a clear-cut idea of how to draw free body diagram. So it is very important that for any engineering mechanics problem, drawing free body diagram as its first step. Then only you can proceed to the next step. So free body diagram is the concept of free body diagram. Once you know, it is very simple to solve most of the problems in engineering mechanics. So let's start with our first problem, which is given here. So this is a circular roller which is held its position by a string which is given in orange line, and a 200 Newton external force is acted upon this roller from center to right direction, and here also there is a weight is also given which is of 200 Newton, and there is a radius of the roller is also given in the question which is of 5 centimeter, and also this string having a length of 10 centimeter. This much data is given here. So this angle will be theta, this angle will be theta. Okay, so let's start with our free body diagram. Before going into drawing free body diagram, I will want to tell you one more thing. Here in this all 5 problems, we are considering the surface as smooth surface. That means there will be no friction. So while drawing free body diagram, we can't see frictional force because we are dealing with a smooth surface in all these 5 problems. Okay, keep it in mind also, that point. Okay, so first of all, we need to draw free body diagram. That is, the body is drawn. Free body diagram, all of us know that in the free body diagram there is only the body and force. Any surface or any other external things will not be considered in free body diagram. So let's begin with the free body diagram. So first of all, we can mark the center of the body. Okay, center of the body. Then first of all, we can draw the common thing, that is weight. Okay, every body have its own self weight. First of all, we need to mark self weight, which will be acting downwards through its center, and it is in straight line. Okay, downward. So we can mark the weight which is given as 200 Newton. Okay, then we have, if a body touches any surface, then there will be a reaction developed. So in this case, this is the surface and the body is touching this surface at its lowest point. So there will be a reaction from this point towards the center. Note the point that reaction will be always acting towards the center and it will be perpendicular to the surface. Okay, this is very important. The reaction will be always developed perpendicular to the surface we are considering. Okay, so we can draw that reaction in this free body diagram as well. So it will be like this. Once we are drawing any force, we need to give proper naming. Okay, the direction and naming of the forces is very important. So let's take the reaction as AR in this free body diagram. Now let's consider any other forces which is given in the diagram. Here we can see a 200 Newton external force is given. So that force we can mark in this free body diagram as well, 200 Newton. And there will be a tensile force due to this string. Okay, there will be a tensile force through this string, so that we need to mark it all in free body diagram. So this will be like this. We can give that tension as tensile force as T. So this problem can be solved by resolving technique. Okay, only if we know how much angle the T tensile force is acting, because the T is the only force which is acting inclined direction. If you draw x and y axis, this is x axis and this is y axis. Okay, so we can see reaction are 200 Newton, and this 200 Newton. All these three forces is acting in x or y axis, but this is the only T force which is acted at an angle. So we need to find how much degree this angle is acting, so that then only we can resolve it into components to find out the value of R and T. So consider this figure once again. So we can see theta here, and this length is 10 centimeter, and we have one more data, that is radius, which is 5 centimeter. So this is 5 centimeter. So if we consider this shaded part, this triangle, okay, if we consider this triangle, we can take sine theta. Okay, sine theta will gives you, sine theta is equal to opposite side by hypotenuse. So here it is equal to sine theta equal to opposite side, which is 5 centimeter, and adjacent side is 10 centimeter. So theta will gives you sine inverse 1 by 2, which will gives you a value of 30 degree. So theta is 30 degree. So the same angle, okay, same angle, theta, same angle, theta will be if you consider like this, the same theta will be coming here also. Okay, that means this angle will be theta, that is 30 degree. Okay. So once I am saying this theta degree is transferred here because we are applying alternate angle concept. Here the angle theta is given as 30 degree, we already found out, and using this alternate angles concept, this angle will be also 30 degree. So this is what we are marking here in this free body diagram. So same thing is marked in free body diagram. So this will be the free body diagram for the FBD for this object. So while solving the equilibrium condition, sigma fx equal to 0 and sigma fy equal to 0, we can find the value of R and T. Okay, so let's consider another example which is given here. In this problem, it is given as a circular object which is placed inside a wedge, which makes an angle 30 degree with a horizontal in LHS, and in right hand side, which is making a 60 degree angle with the horizontal. So here we need to draw free body diagram. So first of all, the body is drawn as usual, and first thing is that its self weight W is marked in this figure, and then we need to draw the reaction. Here there are two surfaces, this is first surface and this is second surface. So there is a reaction at both of these surfaces. So totally two reactions will be coming here, and how will be the direction of this reaction, which will be perpendicular to the surface, so that reaction will be like this towards the center, and it is perpendicular to this plane. Okay, so consider this will be the reaction, and here there will be reaction like this, which is perpendicular to this and which is acting towards the center. And while drawing this, we will get free body diagram, this reaction R1 like this, and there is a reaction R2, is a reaction R2 like this. Okay, this is R1 and this is R2. Okay, then it's our important thing is that we need to find the angle of R1 and R2 which make with x axis. Okay, this is x axis and this is y axis. Okay, only W is the only force which is acting through the y axis. R1 and R2 making an angle. So what is that angle? What will be that angle? We need to find out. So for that we are considering a triangle like this. Okay, let me change the color. Triangle like this, and here also we can make this as a triangle in the form of triangle. Okay, due to the space limitation I am drawing, the triangle will be not perfect. Okay, so first of all, this triangle, we know this angle must be 90 degree and this will be given as 30 degree, so that this angle will be total angle of a triangle we know 180 degree. So this angle will be 180 degree minus other two angles, that is 90 plus 30, that is 180 minus 120, which is equal to 60 degree. So this angle will be 60 degree. So this angle we got it as 60 degree. Then how can we transfer it to the free body diagram into the center? So for that we can consider the alternate angle concept. If we consider this portion, we can consider this same angle will be transferred to here also. So by applying this alternate angle concept, this angle will be 60 degree. So how to transfer this into free body diagram? This angle will be 60 degree, and in this case also we can apply the same concept. This will be 90 degree and here it is 60 degree, and this angle will be 180 minus total angle of triangle 180 minus 60 plus 90, which will gives you 30 degree. So that we can use the alternate angle concept. If this angle is 30 degree, then this angle will be also 30 degree. So we can mark here 30 degree itself. So once you find this angle inclination, you can easily solve this problem as well. This is free body diagram. Consider next example. Here instead of one object there are two objects. So how to draw free body diagram? Let's see. Here in this problem, the bottom angle is given as 30 degree. Okay, so here in this problem we have two objects, so we have two free body diagram, individual free body diagrams. So let's start with the free body diagram of first object. Before that, let's give some name for these surfaces. This is A, this is B, and this is C. Okay, consider this as our first body. Okay, so while drawing free body diagram, first of all, as usual, we are drawing weight of the object W, and then we need to draw the reaction. So this body touches at B and C, so there will be reaction from B as well as C. So from the part of C, there will be a reaction like this, which is perpendicular to the surface. So that can be drawn here, RC. We can name the force as RC, and here B, which is perpendicular to the surface. So the reaction will be like this. Reaction will be like this, and the angle will be 90 with this surface. So here we can draw that reaction RB like this. Okay, this is RB. Then any other reactions is present here? Yes, there will be a reaction at this point of contact between two bodies. So here there will be a reaction through its point of intersection like this, and this will be through this point and will be like this towards the center. So for this body it will be like this, and we can mark this angle as RD. Okay, now we need to find how much angle is making RD with x-axis and y-axis. So let's use a different color. Okay, so RC and W is making its position through its center itself, so there is no complication there, but RD and RB we need to find out. Okay, so consider extend this line to here and we will get a triangle, right angle triangle. This is 90 degree and we will get a right angle triangle, and obviously this is 90 degree, this is 30 degree, then this angle will be 60 degree. So again we are applying the concept of alternate angles. So if you draw like this angle will be 60 degree. Okay, so the same angle will be transferred here, which is 60 degree. And if you look at this figure again, this line, this force and this force will be making an angle 90 degree. So the remaining angle 30 will be present here, so this angle will be 30 degree. Okay, so this is very simple to draw if you know the basic concepts of maths, angles, properties of angle in maths. Okay, so now we can resolve this problem. Okay, also let's consider the free body diagram of the second figure. Okay, if you draw the first, then it is very easy to draw the second also. So we can draw, if there is a point of tangency, point of contact here, through this point of contact there will be a same reaction which is also happening in the second body also. Okay, remember that in mind. So first of all we are drawing weight of the object W, and there is a point of contact at the surface A, so we are marking it as RA here, and this same RD will be also here. Okay, same RD will be also here through this point of contact, which can be marked like this RD. And we no need to find angles again, we can just transfer the angles from this free body diagram. So if we draw free body diagrams x and y axis, then we can easy to mark this as 30 degree and this is 60 degree. Then we can easily solve this problem. Hope you understood. Then there one more example which is given in this figure. There are three balls. Okay, there is three balls. There are three balls. We need to draw free body diagram each and every ball. So let's start with the first free body diagram. Before that, let's mark different points. 1, 2, 3, 4, 5, 6, 7. Okay, so for the first body, free body diagram, first body will have a reaction like this. First of all we need to mark the weight, right? So we mark weight first, and there is a reaction from R1 from this point, then there is a reaction from R2, and there is a reaction from fifth point R5, and there is a reaction from a sixth point R6. Okay, this much reaction will be there because this particular body, the body A, will have a contact at 4 different points. 1, 2, 3, 4 points it have contacts. So 4 reaction will be there, and additionally one weight component will be there. Here also there is weight component first. After marking weight, we have a reaction from 6th point R6, and there is a reaction from 7th point R7. Okay, then consider free body diagram of C. Here for this C, first of all we are as usual marking weight of the body, then there will be a reaction from the 3rd point R3, and there will be a reaction from the 4th point R4, and there will be a reaction from the 7th point R7 like this, and there will be a reaction R5 from here. Okay, so note that the reaction or the point which is common to two bodies, their reaction will be also same. This R6 will be same value will be here also, and this 5th point is common to A and C, so this R5 value will be like this two body. So these all forces will be to the center. Okay, so these all are about the concept of free body diagram. So it is very easy if you once you understood the concept. If you have any doubt, free feel to contact in the comment box. So thank you for watching this video.